So, everyone, thank you for rejoining. Welcome to the EMEA region of vJUG24. We are 1/3 down, 2/3 to go, and to kick off next 8 hours, we have a keynote from Steve Wallin and John Dwimovich. So we're going to be talking about Java in the 21st century. Are you thinking far enough ahead? And we'll say hey to the speakers in just a second. I just got a few other bits to mention about our sponsor and participating JUG. So we have Lightbend, our sponsor for this session. We have 3 keynotes, and each are sponsored by our gold sponsors. So thank you very much, Lightbend, for sponsoring. And we have Pakistan JUG. So we'll be looking for maybe some questions at the end of that. So yeah, Lightbend are actually partners of IBM as well. They're connecting a lot, obviously, with the kind of we love Scala and Java movement, and there's going to be a lot of good things coming out of that, I'm sure. So thank you very much to Lightbend for supporting the Java user group. Okay, so let's talk to our speakers. So John and Steve. So John is the Java CTO and distinguished engineer at IBM. Hey, John, how's things?
Pretty good. Thanks. Thanks for hosting this. This is a great event. First time I've done it, so but things are looking good.
Awesome. Yeah, we have only had a couple of minor issues, nothing too bad just yet, but there's still a long way to go. So, John, whereabouts are you? You in Toronto, back home right now, or?
Well, I live in Ottawa, but I happen to be in Toronto because I'm here visiting a couple of my teams here, so I happen to be on the road.
Oh, perfect.
But it's close enough for estimating. I'm in Canada and I'm in Toronto at the moment, but I live in Ottawa.
Okay, there's a lot of Java development at IBM in Toronto, right? Is that where most of the team is?
There's a fairly large lab here, a couple thousand folks, and in Ottawa another over 1,000 there, and I won't say all, but the majority have some sort of Java development role. JVMs in Ottawa, there's a runtime team here in Toronto, there's a lot of tool teams here in Toronto, and a lot of Java users. So
awesome.
It's a big Java population, lots of skills.
Cool. Well, welcome to the virtual JUG and vJUG24, and also we have Steve Wallin,
hey.
Program Director of IBM Runtime Technologies. Welcome, Steve.
Hey, thanks, Simon. Good to see you again.
Yeah, and look at that office behind you. Is that DE3 in Hersley?
No, we're actually over in G now. So yeah, if you you remember your building names.
I do. I remember my 12 years at IBM, so I do.
Yeah.
It does actually look quite like DE3, but
yeah, so we got the Node, Swift, and Java teams all around me, kind of in the office here. So awesome.
So I feel like I feel like this conversation is probably only interesting to IBM. So we'll move on. But so hey, it's good to see you at Java 1 just recently, and I was very impressed with all the work that IBM's been doing very recently. IBM are also sponsors of the vJUG, and earlier in the APAC region, I showed the slide with a number of things that IBM have been doing, including open sourcing Liberty, open sourcing OpenJ9, and the work that they've been doing with MicroProfile. So some really exciting things that we have, and it's a pleasure to have you guys join us on Virtual JUG24. So without further ado, let's get started. So who's going to take control first?
I'll get my screen going. Here we go.
One second, please. Before we start, I just, as a host, I have a couple of things to mention to everyone. So if you are just watching that, if you just connected and you're watching us live on the vjug24.com, there is a link to the Slack channel where you can join. Anyone can join, and then on the channel live session, we have the discussion about the ongoing session. You can ask all the questions there, and we'll try to forward them to the speakers appropriately. If you're on social media, then the official hashtag is hashtag vJUG24. And if you're we're using YouTube streaming platform, so you should be able to increase your video quality up to HD at least. So do that if there are any code snippets that will make wonders to make them more readable. That's just a short organizational thing. Other than that, we have nothing introductory more, and off to you, John and Steve.
Excellent. Thanks very much for the introductions. Hopefully you can see the chart I've got on the screen there now.
Yep.
Excellent. So thanks for the introduction, Simon. There, I think you're right. There's been a huge amount of change in the Java ecosystem and the way that IBM's approaching it at the moment. and it's been really good to get the feedback from developers and from the broader community as we've gone through the big open source shift that we're in, and getting the real feedback and working in a new way for a lot of the developers that we have here at IBM. So we've got a lot of material to get through today. I just kind of open it up by really talking about what does Java Future mean, and depending on your starting point and the problems that you're really looking to solve as a developer, each of us really do have quite a unique set of future paths ahead of us. If you're back on Java 6 or 7, and I hope you're proactively moving off Java 6, then your immediate future as you look at Java 8 and 9 is kind of already known and certain. But then there are a number of experimental things. So as we look forward to 18.3 and 18.9 and the more rapid release of Java that's coming, there are things that we can get involved in that I would say today are partially coded or experimental. And then I really want to try and stretch as we get towards the end of this session onto some of the more hypothetical or far out kind of ideas that are going to maybe not necessarily directly affect the way that you code Java, the way that you deploy it, the way that you manage your applications, but actually could be much more disruptive in their nature. So I think in the Java ecosystem, we're starting to get into that pattern of seeing incremental improvements, but actually I do see some kind of disruptive and major changes on the horizon. So John and I are going to try and cover a bit of all of these things. But in reality, this session is only just a thin slice, through the broader Java innovation, which is happening right now. And I think it's definitely rampant in all the communities. And we as developers and as Java developers need to try and keep up with some of that. So hopefully this session can provide some pointers and some introductions to some of the things you may have heard of, but also try and stretch your imagination a little bit and challenge each and every one of the developers listening to go look at something new. So from my perspective, really the future of Java is now open source. There's been some great announcements that you've seen around Java EE moving to Eclipse, as well as OpenJ9, MicroProfile, and a number of other things, kind of finding their home in some of the more open source foundations. And this is really driving open innovation. So how do we collaborate in the Java ecosystem in an open way in order to define that future state of Java and of what developers do on a daily basis. Now, one area that I've certainly had a lot of questions on and that I've seen in the Slack channel for the vJUG is about Java evolution. And so, historically, Java has tended to come along, a new release every 3 or 4 years. And it's been very difficult to plan or understand what's going on in Java because most of the releases in recent history have slipped and it's been very difficult to kind of keep up with what's been going on and when you can really get the next set of technology in Java. Java is now going to be on a predictable, consistent release cadence. So every 6 months, there will be a new Java SE platform and that will really define the rate and cadence of which you can pick up new and great technology in Java SE. Now, given those releases are going to be more consistent and more frequent, hopefully the level of change that you get in each of those releases is going to be less. So that will mean migration between each of these Java platform versions should be easier and much more simple. And I think the aim of this is really to demonstrate increased innovation in the Java runtime. So, when you compare the broad range of languages that are available to developers today, I think, when developers look at languages like Node or some of the other things that have been bubbling, Go and Python, for instance, there's a perception that those languages are coming thick and fast and that they're moving very quickly. Now, in reality, if you look at the amount of content each of the Java releases, I think each of the languages are probably evolving at a relatively even pace. The challenge is the perception because those other languages are coming faster and the gaps between those versions are smaller, that Java is actually lagging behind. So Java is going to be becoming much, much faster than it has in the past. So there's a few things just to really touch on there. There's a new numbering system for Java. So from next March, the Java numbering system will move to a year.month system. So the release after Java 9 is currently planned to be 18.3. And then the release after that is 18.9. So you can see that 6-month release cadence coming through there in the numbering scheme. So next March and next September are the 2 versions that are coming. Now, with the new numbering system and with the 6-month release cycle, there's a new long-term support model for Java releases. So people have been very used to 6, 7, and 8 having support for I don't know, 8, 9, 10, 11 years. Now, each of these 6-month releases isn't going to have a long-term support associated with it. Instead, every 3 years, starting with 18.9 next September, those releases will actually be the long-term support model for Java. So every 3 years, one of those 6-month releases will be picked as the LTS, and it'll essentially be a 3-year gap between those long-term support releases. And it is going to take time for us as developers and the operations team and others in our kind of larger ecosystem to adopt to this frequent release of Java, and to actually try and adjust our stacks and our deployments to manage how we're going to support, how we're going to make sure we keep getting security fixes and those types of things with our Java platform. I just wanted to share a couple of charts from Oracle's support pages. I've included the link at the bottom there, just to really demonstrate to people and to help understand what dates they need to be focused on. So today, Java 8, the end of public support. So if you install Java on your laptop and you have a default system JRE, you automatically get security updates every quarter. Those are going to continue until at least September next year. Now, with Java 9, those security fixes, if you use that as your JRE or JVM, those are only going to run until March. So Java 9 is a short-term 6-month release. And next March, you'll need to move to 18.3 in order to keep getting security fixes on your Java version. Okay, so this model is really starting to kick in as we get through to the beginning of next year. Now, just to kind of reiterate that in terms of what people have been expecting up to now, Java 8 is going to be supported in public terms for at least 4.5 years or later, according to the star on the bottom there. Whereas you can see the pattern that we're going to start to see in terms of public support for the new releases, Java 9 and forward. Now, from a commercial perspective, Oracle's pages describe Java 8 and Java 18.9 as the 2 main LTS releases that are in support now and will be coming as of September next year. And people really need to think about how they're going to be getting Java and how they're going to be getting fixes, security updates, and capabilities around their Java technology going forward, because the pattern that they've been used to in terms of receiving Java and using Java is going to drastically change as they go through the next year. Our perspective and the community that we've been working with, especially around London Java community and other partners, is focusing around how do we provide completely open Java technology. So open source in terms of the JVM and class libraries, open build in terms of the build infrastructure and getting through a build pipeline, and also open test. And so we've been focusing on working with others at Adopt Open JDK to create that open source, open build, open test environment for hosting and creating binaries of Java technology that people can come and depend on. So what we really want to get to by September next year is the ability to have that open end-to-end infrastructure around these LTS releases, so that you can have security fixes on a version of Java that will take you from the LTS release to LTS release, and also to have the latest 6-monthly increment available for developers to do development and test against and prepare for that next LTS that becomes available. All right, so just a quick walk through the base Java E technologies that come along recently. So if you're back at Java 7, then there's quite a few pieces of technology that you really should be looking at. And there's been some great sessions, in vJUG24 and other conferences recently around all of these technologies. So I'm not going to go into them in too much detail. But if we look at, things like lambdas and streams, coming in Java 8. So when you look at lambdas, this is really about being able to have a functional style of programming attached within your Java code. And this can be seen more broadly than just in the code that you write in Java, because the idea of functional programming is kind of extended well beyond just the Java concept. And as you look at cloud technologies and serverless styles of programming, things like Apache OpenWhisk, the FN project that was announced at Java 1, Amazon Lambdas, really do stretch the imagination when it comes to being able to open up functions, use functions. I think combining lambdas with technologies such as streams really do come into their own when looking at big data projects, when looking at technologies like Spark and frameworks that really come up from underneath. And really, for me, streams are all about improving collections and trying to get through those collections, in a much more effective way. And when you start to then move into Java 9, where we have a new, I guess, specification around reactive streams, the interest and the level of innovation that's happening around that kind of technology is really rife right now. And I think a call out to the sponsors of this session here. If you're looking at reactive streams, then Lightbend do have the akka framework, which is a great implementation that really does sit underneath the specification that came in Java 9. There was a great talk earlier on today on modules. So again, I won't go into a lot of detail. We will touch on modules in a few charts' time, just to look at some of the challenges and some of the opportunities that they offer when it comes to containerization. But really, I want to just try and spend a couple of minutes now looking at those projects that are going to be coming as we look at 18.3, 18.9, and further forward. And I think what we'll see is, instead of these projects landing lock stock as we saw for modules in Java 9, we'll actually see incremental value from each of these projects that are running. Now, the great thing about Panama, Valhalla, Penrose, Amber, and Loon is that you can actually go and join in the conversation at OpenJDK. So I'd encourage anybody with an interest in some of these areas to go do that. So let's start with Panama. So I don't know how many people on this session actually write JNI code or have to interact with native objects or native languages. Panama is really about how do we improve the interface that we have, both in terms of looking at memory and interacting with C and COBOL and other languages that have kind of a native background, but also how do we improve JNI, right? I think JNI is as a programming model, quite error-prone and difficult to get right. And I think it's proven over the years that a lot of errors can be introduced in larger applications when you try and use things like JNI. So how do we get to a place where we have a much easier model, a much better programming model, and much less error-prone and easier than it is today? So Valhalla, this is a project really looking at how do we have a new model of interacting with objects. Okay, so today, if you compare primitives with objects, primitives are lightweight, fast, efficient. The way that they're represented and stored and manipulated within the JVMs are orders of magnitude more efficient than having full-blown objects. So you can compare the int primitive to the Java lang integer object. Now, the number of operations and the things you can do on an int object is obviously much smaller than an integer, but the efficiency with which you can drive, calculations and kind of big data applications within are much more efficient. And so Valhalla is a project really driven to try and get reference-free objects and a much more efficient by value computation with non-primitive types. And so I think we'll start to see some of those things creep in as we start to get to 18.9. Penrose, and I've already only picked this one and included it in the list because this just represents one of a number of areas where I think we'll need to continue to look at the new module system and enhance it for real-world applications. So Penrose has been focused about how do we bring the new module system and OSGI together. But I think, in general, there's going to be, as people look and adopt and develop and test against the new module system, there's going to be a number of areas where we're going to really want to increase our abilities to incorporate the module technology into what we do on a daily basis, the build and DevOps pipelines, as well as existing technologies that we have in our Java stacks and frameworks. Now, Amber, I think actually one of the main JEPs for Amber, or one of the first JEPs for Amber, has already landed or is about to land in 18.3. And this is really around value types. And how do you get, not value types, is local variable type inference.
Type inference.
And really type inference. And so how do you get much simpler code? How do you get more readable code? And how do you get the compiler to do a lot of the work for the developer? All right, so the example here is, you can have var list, and instead of having to hand code, the type of the object that you're actually interested in for list, and in this instance, it would be an array list, you can actually let the compiler do that work for you and end up with much smaller, simpler, and cleaner code as you go through. Now, one project that hasn't actually been created yet, but that has been suggested, is a project called Loon. And this is really about how we look at threads within the Java ecosystem. So today, the JVM implementations typically take a thread and actually let that drive down to an operating system thread. And so Loom is about how do we make a much more lightweight threading environment for Java, so that rather than relying on perhaps the heavyweight threads coming from the operating system, we can have a much more lighter weight dispatch system, so that developers can scale out the threading architectures to much, much higher numbers. All right, so I'm going to take a break there and take a deep breath, and I'm going to let John pick up and talk a little bit about containers and the way that they're changing the behaviors of developers and the way in which we approach cloud services.
Yeah, so thanks, Steve. Yeah, so containers, we're going to...
I'm sorry,
sorry
guys. Do we want to broadcast the slides on Steve's computer with John just talking over?
Yeah, that was the plan, so I wouldn't have to drive, but
okay,
that's fine.
cool.
That's good.
Or you can share your screen. That's completely fine.
I don't think I have the exact copy that Steve has put up on the...
Okay, cool. Then we're going to run with the slides on Steve's machine, and John, it's all up to you.
Thanks. So I'd like to see the chart somewhere. Yeah, so containers, we talk about containers are a way of life. This is because containers have become the de facto way to package up microservices, a full stack of everything you need to deploy a microservice into the modern cloud using things like Docker, which is a kind of container. There are multiple implementations of containers, and using orchestration and management facilities like Kubernetes. And so when we look at what's happening in cloud, containers are a delivery mechanism for microservices, and what that is doing to us in terms of the VM implementers and the stack implementers for both SE and EE is looking at how we can optimize for containers, because we now have to live with containers. And the two things that hit us initially are what we call cloud dynamics. Dynamic behavior in terms of containers come up and go away quickly. So that's a microservice that is either being recycled because it was unhealthy, or it's being scaled up, so you need a lot more. So dynamic behavior is the new normal. And since the Java VM is a kind of container itself, and then the native container is a kind of container itself, we have to work to make those things seamlessly interop without fighting. So you don't want the Java container to take unlimited memory while the outer container is trying to restrict your memory, and those kinds of things, resizing, and those kinds. So there's a significantly bigger set of dynamic behavior that we're addressing. And the other one is footprints. Because you're going to be running more and more and more copies of Java, there is a need to drive a much smaller footprint. Some of the features even Steve talked about, we're going to be able to reduce footprint. So projects like Valhalla, which have value types, if you have an array of value types that were, say, integers or points or something that used to be an array that points to another object, those you'll be able to have array of a complete inline thing in your Java VM, which will be significantly smaller than the previous format in memory, and so allow you to create much tighter essentially packed data structures, as opposed to having a big tree of objects. So some of the base stuff in SE is driving to footprint. And we've been looking at significant other changes to make footprint significantly better. So if we could, I'm going to talk about each of these. So microservices, the interesting part about microservices is you don't have to change a lot about what you do, but you do have to add capabilities to your existing platform to be able to do new things. So the example in this case is at Eclipse, which is now the home for the future EE, which we'll probably talk about a little bit, but also a project called MicroProfile, which is creating new technology that allow you to create microservices with your existing EE infrastructure. Things like handling failover. Yeah, that's a perfectly good chart to move forward to. Things like handling timeouts, things like handling health check, the kinds of things that you'd like to take your existing app and add new capabilities to, so that you can deploy it as a microservice. And so growing your existing skills forward. And the way it's being done isn't just IBM going forward and proposing this new thing. We're doing it with partners, really the community Java way. And you can see on this page that's currently displayed, we have quite a few partners, Red Hat, we have the London Java community, lots of worldwide participation in driving what I say is the creation of the next generation microservices platform. Okay? So this is something to watch if you want to learn. How are we participating in the open ecosystem is something that, as everyone has noted, is a fairly large change. I was just going to make sure that if you haven't seen it, go check out things like Open Liberty. This is a full open source implementation of Java EE and an implementation of MicroProfile. So it has both sets of APIs. It's under the Eclipse license. We have Docker containers. There's a seamless path. So I will shill for IBM, apologies, but there is a seamless path to go start Open Liberty, be an open source developer. But if you really want to buy support and other things, there is a seamless path to go into the IBM support upgrade without changing any of your code. It's not a different version, it's the identical version, okay? So what I want is, if you're interested in it, just go try it, go get started. One of the things we're trying to do is make sure every single piece of software that we have, that we brag about innovation, but we made it impossible to get in the past. We're now bragging about innovation and cool things we're doing, but it's really easy to get. So go download either Open Liberty, go give it a spin. You can hack on it, that means go get the source code and play around. You can just give up binaries available, just go see it at openliberty.io. Or you could use tools that we've been putting together like Microservice Builder to do an end-to-end deployment on a Docker Kubernetes system. So a lot of this stuff is new. So one of the easy ways to do it, you look at the link we have here. I won't talk too much about it, but if anyone has played with Docker, you've installed Docker, you've installed Kubernetes, and you might even have installed a bunch of other stuff, messaging and other stuff. There is a free bundle of a bunch of stuff that we put together for running what's called IBM Cloud Private, which is essentially a Docker Kubernetes environment that you could even install on your laptop. And we put together that GitHub URL so you could just use Vagrant, create yourself a little 3 or 4 node cluster, and experiment with Java, Microservice Builder, MicroProfile, and do an end-to-end scenario using the new container microservice model. So I know a lot of folks may already be on this, have done experiments like this, but a lot of Java developers are still new. So we like people to be able to go and put this all together really easily and learn about it. So I would encourage you to check out these links and find out more, okay? Cloud Dynamics, I do want to talk about what we've been doing on Cloud Dynamics. So one of the things we've been doing in terms of Cloud Dynamics is, well, in this case, this is a footprint one. I think the charts may be in the wrong order, but we'll just go with this one. In this case, the aspect of cloud that we're trying to optimize is footprint, because in many clouds, including the IBM ones, but in many clouds, you pay by the megabyte or pay by the gigabyte. And so once you're starting to pay for footprint, you're going to actually care a lot more about how much footprint you use. So we've been spending a lot of time optimizing Java itself, so it'll take any application and run it significantly in a significantly less footprint, but maintain the throughput. So in this case, we have a benchmark, and won't belabor the point, but with OpenJ9, which is our open source IBM JDK, running with the OpenJDK libraries, of course, in this case, it's even better than 2x smaller. So we see the need to continue to drive footprint smaller and smaller and smaller, because you're going to be deploying more and more and more microservices, and they add up. And if you have to pay for them, it's going to be expensive. So we're focusing a lot on not losing any throughput, but still having small footprint. Okay, so we can flip there. The Cloud Dynamics, so this one is a Cloud Dynamics, that's nice. So what we've noticed is because if you have because you're recycling containers frequently, so the DevOps model, the 12-factor reconfigure model says the way you reconfigure is you destroy the old container and you bring up a new one. Well, we all know from our Java history for the last 20 years that starting up a Java VM may not be the fastest thing historically. But we've been looking at startup performance, and we've been also looking at what we call ramp up. So how fast can you go to peak performance after you started your container? So if you're starting and killing containers all the time, the just-in-time compilers don't have enough time to warm up. So we have in OpenJ9, so all open source, technologies that ramp up quickly, but also allow you to ramp up quickly so that you get to peak throughput sooner. And we do it with a mix of optimized JIT code generation, try to do a lighter weight version that gets you there sooner, and runtime profiling, runtime instrumentation so that you know what's going to happen and what you should be doing first. But we also do it with dynamic AOT. So we've taken code that you've run previously and cached it away and reuse it in subsequent runs. So starting 100 containers, they all benefit from the fact that some of that code is available to them and allows them to start quickly. So it's a dynamic AOT. It's JITted code that you can save so that it's available ahead of time for people who start later. So it's kind of a cool feature. And you can see here, we actually start and get to ramp up speed significantly faster than, for example, Hotspot. But I suspect that, the competition in the industry and the open source projects like ours that are pushing the limits here will drive an improvement across the board for this kind of performance behavior. So, and it's pretty nice. So I was going to ask on the, since I don't have a copy of these charts live on my desk, what's coming for footprint, Steve? Okay, so this is actually something that's it's an interesting. I think there's a build out here of three more things. If you could just show them now, Steve. So this is a kind of an interesting thing that I want to talk about a little bit, in both in the footprint context, but in moving to Java 9. First of all, Project Jigsaw, a heroic effort and a very interesting. Well, actually, they successfully shipped, so I want to congratulate them publicly worldwide on this call, because it was quite an impressive delivery. That allows you to restrict enforce the restrictions of what you want to see modules by module. So it introduces modules, I should have said that earlier, and allows you to create modules that control what other modules use and can declare what dependencies that module has. Okay, so that you know everything your application will need because of the dependencies, and you can control anything that you'd like to support as a public API for other modules to depend on you, which makes it a lot easier to migrate and move forward. So as a software engineering concept, modularity plus all these controls on access and visibility and those kinds of things help you, drive, well, actually will help us drive Java faster, because we'll be able to guarantee that people won't be using secret internals that we would like to change, but we're not sure we can because something uses them. So, so the reason this chart's up here is because Java 9 is a bit of a bite to take if your application is using internals. So there is this permitted legal access that will allow you to move to Java 9 and experiment. So if for the developers in the audience who really want to see what's coming, I would highly recommend to go to Java 9 to figure out what it's going to take to move your application to it. And that's going to take potentially a little bit longer than maybe previous upgrades. But then by the end of it, you will be soaking in modules. Okay, so that will be a pretty good value. And the reason you want to soak in modules is, one, the self-contained app. There's a picture on there that says app. That just means that you'll be able to create an app that's completely, the contents of it are completely known, not just random dependencies that you don't really understand. You'll be able to use that and use things like JLink, which will throw away all the modules you don't need and allow you to create a very small linked JRE that's custom for your application. Why is that important? Well, you'd like to then be able to package that with your Docker container and ship the smallest, lightest Docker container, which will make deployment faster and startup faster and lots of other things faster. So it is yet another way to get smaller footprint, because why would you bother shipping things that your app doesn't need? So the Java platform is growing into that mode. So yeah, continue. I'm probably running slowly, so I'm going to. So the third one I want to talk about is something that we have in the pipeline that we've been looking at. It's called the JIT as a service. So the best way to motivate this is if I bring up we'll talk about a deployment. I'm going to bring up 100 Docker containers, and each Docker container has a JIT in it running Java, and each one compiles object and string and every other class in your application multiple times. And in our current system, we can share some of that by putting in a dynamic AOT cache, but we're looking at moving that into a service. You've got more charts than you're going to go forward. We're looking at to make it into a service. So one thing is I compile object once, and I can make it available on the set of apps, as you can see in this picture. Okay, the set of apps would then benefit from a couple things. One, only compiling once and share anywhere. So I'm going to say it here, not just write once, run anywhere. Compile once, run anywhere. Okay, and that will allow us to drive a much more dynamic infrastructure plus smaller. So this is something that we're going to be looking at trying to drive for the smaller and smaller footprint. So for example, immediately you can look at savings of a couple hundred megabytes for the JIT scratch space, 8 megabytes for the ROM footprint, and you can throw that out of your app and drive much smaller and smaller apps, which means that microservices will start to be a lot more micro than they used to be in the past, okay? The interesting thing is this is a formula that we're using for exploiting cloud technology for developers, and it's a theme that comes up over and over again. So one of the neat things that we talk about in JIT as a service is the ability to compare performance runs across the cloud and use essentially hundreds of profiles instead of just one for your app to drive better performance at scale. Okay, so being able to use crowdsource, or not crowdsource, but get bulk profiling information and drive some interesting new performance optimizations that are in that list. Okay, so I see Steve trying to drive me to go faster here with the JIT as a service discussion here. So anyways, to sum up, we have things like linking, which I talked about. There's JIT as a service, which will allow us to create things like significantly smaller Java applications that can still do all of the stuff that the JIT supports, dynamic optimization. You could do bytecode injection and still get all the normal behavior you have, so that's a compatibility statement. If you go to strict AOT or static, you might lose some capabilities, so there's trade-offs there. So the JIT as a service we see as something that we're going to develop over the next while in OpenJ9 and deliver that. And of course, the developer experience, I do want to mention that a little bit. We see the need for leveraging what I would say cloud technology for developers, okay? And when I talk about that, I talk about it in all stages. I mentioned a little bit of JIT as a service. We talk about, can I use a cloud like Docker to deploy my application more efficiently, and what would I change Java to, and how would I change Java to more effectively take advantage of that? We also talk about it for developers. Can I deliver a ready-to-run full stack using a container which has all this stuff already embedded, so you don't have to install anything on your desktop, and use that as a way for you to get started with all these different stacks that are coming down the pipe. We have people use Spring, they like it. People use MicroProfile, EE, they like it. People use Lego and Akka and our Lightbend friends message passing stack, and they like it. And we want to be able to have a very nice common user experience that is delivered via cloud and deliver better developer experience. So I don't think we have more on that one, but I think it's something that if you see me somewhere, just engage conversation, just say hi, and we can chat about it. So we have a lot going on in Java. So I don't know how we're going to finish on time today, but we have a lot going on in Java, and this is essentially our thought process here. We work with a lot of customers, we work with a lot of end developers, and we've always said, hey, we should work together, and it's never really been possible. But what's made it possible for us, and we finally got there this year, is to have a full OpenJ9, a full version of Liberty, a full version of MicroProfile, and now with EE joining there, Eclipse with EE for J, and how that evolves. I think we have a really great place for us to go and drive Java forward together as a community in the open for the next 21 years. And you can see on the list on the right, there's a whole whack of projects that you can go and get involved with, depending on what problems you have to solve. So you look on the left-hand side. What itch do you want to scratch? Do you want to be a VM developer, which I would love, because come and talk to us. Would you like to be in Liberty or EE developer, or influence it in something that you really wanted done to the platform? You can do that at either Liberty, or you can do it at EE for J. If you want to do more things around making sure that even contributing to OpenJ9 to make sure that there's a long-term support for Java 8 or Java 9 or different versions that really do. So there's lots of ways to get involved, and that's why I'd like to encourage and pick a lot of projects that we're involved with. We'd love to work with you on. So I think I'm going to run out of time, Steve. So I think you wanted to talk for a while too. So
yeah. So I think that just gives a quick summary of what we're seeing happening in Java SE, the class libraries, the APIs, the things that you can rely on as a Java developer, and how they're going to evolve over the next year or so. And then John really covered some of the deep VM elements and some how we're seeing some of the trends around the cloud and containers affecting. But I wanted to try and finish with kind of a real world problem. Right, so right now I'm seeing the challenges that developers being given are different. Right, they're transitioning to be much more big data style problems, much more how do we use machines to cognitively look at this huge set of data and give the user a much more intelligent set of help. Provide a spreadsheet or provide an array. It's actually for the machines to understand what that data means, and to provide much more intelligence back to the person trying to do some analysis. And so I've been thinking about, okay, how can we talk to developers about the frameworks that are already available in Java today that they may not be aware of, but also looking further into the future, what sort of things might come along that's going to help them. So let's just take a really simple problem that I think everybody is aware of, right? Let's think about a word search. Now, when I learned to program a long time ago, it's easy, right? You have a nested set of for loops. You go from the top left of the word search, following each of the rows down the columns. You have a couple of if statements to look for the first letter of each of the word in the word search. And if you find one, you look around and hopefully you'll find the word that you're looking for. Right, so this is a really simple solution to the problem that's been posed. And I think as a developer, that is generally the tendency. Is I have the skills, I have an understanding of how to build algorithms, and that's where a lot of people tend to go when they want to solve a problem using Java. Now, what happens when that search grid gets to be 1 million by 1 million elements, right? When you start to introduce actual big data style problems. Well, in Java, we're quite lucky, right? Because we have frameworks like Hadoop and Spark and Akka, where you can actually break that problem down, distribute it across a number of different nodes, and actually solve the problem by partitioning it down into small segments, right? Java is absolutely fantastic at this, and we have some really great frameworks to do that. And typically what we find is people use the CPU in order to solve those problems. What we're seeing more and more frequently is where the CPU just isn't good enough, especially when you have very large data elements. And people are more and more turning to offload that to things like GPUs or FGPAs and ASICs. So when you look at things like Bitcoin, right, that whole market has really shifted. If you want to mine Bitcoins, you're either GPU or FGPA or ASIC enabled. Now, from a Java perspective, I saw actually in some of the Slack messages this morning, people asking about GPUs with Java. So if you pick up OpenJ9 with Eclipse, OpenJDK9 with Eclipse, OpenJ9, or the IBM SDK for Java 8, there is actually optimizations and GPU offload in that code base. And what we see is, we've got some heuristics in there to basically look for when you're doing parallel work in Lambdas. And if you have more than about 30,000 elements, that's the point at which it's more efficient to offload to the GPU. So until you have a search data set that's actually big enough, you're better off keeping it on the CPU rather than going through the effort of offloading all the data to the GPU. But when you do that, and when you get up to maybe 100,000 elements or more, you can actually see 100x improvement in the performance of algorithms like sorting. So from a JIT perspective, we have the technology to auto offload to GPU, or as a developer, we also have Java APIs that enable you to code in CUDA expressions. So there's a CUDA for J set of APIs that allow you to offload to GPUs. And I think this is going to be a trend, right? It's going to be, how do we take the problem spaces that we're trying to solve and use different pieces of technology with Java to optimize and get our answers faster than perhaps we've done before. All right, so what we've just done actually is what I think most developers do, right? They see a problem, they create a solution, they realize that there might be a problem that's slightly more complicated than the answer that they've come up with, and then they generate and create a whole big set of infrastructure in order to support the worst case. Now, in reality, what I should have done is gone back and talked to the user and say, okay, I've got this word search problem. What is it that you really want me to do? Right? Now, the reality in this instance was they just wanted to use their mobile app, point the app at the newspaper, and actually have a system solve the word search for them via the camera on the phone. Right? So what do we do in that space? And I think this is where things like optical character recognition and some of the neural networks that we saw in a session 2 hours ago start to come to play. And again, in Java, we have things like deep learning for J, Neuromorph, IBM Watson, TensorFlow. There is a whole bunch of sets of APIs now that we have for solving these kind of neural network solutions. And again, just a shout out, I think on the last day of Java 1, deep learning for J is also at Eclipse. So if you're in any doubt about where the open source kind of gravity is falling with these projects, it's definitely tending towards Eclipse right now. Now, not only can you build neural networks in software, but we're seeing neuromorphic processors start to emerge. So these are essentially very low power chips that have the ability to process neural network algorithms very, very efficiently. So we're seeing them being used in drones for object recognition on land. But ideally, what we'd like to be able to do going forward is to try and take those algorithms in Java, where we know we have neural network type infrastructure set up in software, and actually auto offload those to things like neuromorphic processors or neural network processors. I think, again, that is the next evolution of where we might get to from GPUs. All right, so I just want to come back to search, right? Search is a problem and how we do search on classical computers, which is what we're using today. So on the machines that we have right in front of us, search is essentially an ON problem. So that's represented in the graph below by the red line. It's a proportional line, so the bigger the search surface that you have to go through, the longer it's going to take. Very proportional and directly linear search problem. Now, in '96, there was actually a new algorithm created by Lou Grover, and this transforms that search problem domain into an O square root n search problem. Now, that's represented here by the blue line. So you can see the bigger the search surface, or the bigger the domain you have to search, the more efficient that algorithm becomes. Now, the one challenge you have with the Grover search algorithm is that it was designed for a quantum machine. So you can't actually use the algorithm on the classical machine or the Mac right in front of you now. Now, let's just do a 30-second introduction to quantum mechanics. So hopefully nobody's a PhD physicist on the call. But essentially, as software developers, we've got very used to dealing with ones and zeros, right? The classical bit. Now, if you go back in computing history, you would manipulate these bits with and, or, and not gates, and you'd create circuits to solve the problems. And over the years, we've created, instruction sets and opcodes and assembly and all the different languages that compile down to essentially manipulate zeros and ones in memory and on disk. Now, with quantum computing, what you have is essentially the idea of something called a qubit. If you think about a sphere, okay, so if in your head you think of a sphere, and a line pointing to the North Pole represents 0, and a line pointing to the South Pole represents 1. So you can think of that sphere as being able to exist or be able to be observed in two states. One is where you're pointing north, and one is where you're pointing south. Now, unfortunately, I couldn't get Schrodinger's cat to join us on the call today, but what I did actually get was my cat, Fernie, and she's an expert in quantum mechanics, so hopefully she can help us out here a little bit. So what you can do with qubits is, as well as being able to point to 1 and 0 when you observe them, you can put them into something called a superposition. And when they're in that superposition, they can essentially point to anywhere on that sphere. Now, you can't observe the qubit when it's in that state, because as soon as you do, it flips to either representing 1 or 0. But while it's in the superposition state, you can manipulate it, and you can basically amplify the direction that the internal state is pointing. And you can entangle that qubit with other qubits. So what it lets you do is you can set the state across a number of qubits. You can entangle them. You can set essentially logic gates on top of those qubits to manipulate them and amplify the signals in a way where I call it the magic happens, right? So you can actually represent a much broader set of domain artifacts than you can with a classical 0-1 bit. And once you run the set of gates and algorithm through, you essentially observe the qubit states, and that will give you the data back that you're looking for. So it's not quite magic, but it almost is. Now, what we're seeing is the rampant pace of innovation with quantum computing going faster and faster and faster. Now, what you see here is a graphical representation of the IBM machine that we have. And it's a beautiful piece of engineering. The IBM machine uses superconducting loops to hold particles right at the bottom of the machine. You can see on the left there. They're kept near absolute 0. And what happens is there's a canister about the size of a dustbin that fits over the hardware that you see on the left. It's filled with a cryogenic kind of material to keep it cold and actually manipulate particles one at a time. Now, the great thing about quantum is you can go and play with it as a developer yourself today. So IBM's machine is up there on the web, on the IBM cloud. Now, what you see on the top right is essentially a logic circuit for a quantum machine. So it's the equivalent of the and, or, and not gates that we used to use in order to create software and algorithms for the machines that we're using today. And that's the kind of era that we're in for quantum, right? We're right at the early days. Now, the challenging thing is quantum can be used to come up with the probable states of where the words that we're looking for in our word search are. But I think the scary thing from a Java perspective is what's going to happen when we start to use larger quantum machines on things like factoring. Most of our security and encryption today relies on the fact that factoring large numbers is a very difficult problem. As we see these machines getting 50, 100 qubits, all of the cryptography methods that we have today are going to start to become at risk, right, in terms of how we're going to secure, manage, and manipulate data going forward. So you can go play with a quantum machine. There's a 5 and a 16-bit quantum machine up there for you to play with today. And I think as we look at GPU and as we look at neural networks, wouldn't it be great if the algorithms that we're writing in Java today to solve our search problems could be automatically offloaded by our JIT to something like a quantum machine to drastically accelerate the performance? So there's a massive opportunity, right? As we look at the explosion in data that's getting created, I think Java is at the center of most industries as you look across the ecosystem market that we have today. And I really do believe the world is being reinvented in Java code, right? I want to challenge you as a developer. How do you think when you approach a problem about looking at the available frameworks that are already in existence? How do you think about expanding your knowledge and going and looking at new things to try to solve the problems that you're given on a daily basis? And I think Java is going to succeed by making sure that we partner and embrace and use new frameworks, new hardware, new technologies, and other languages. And as we build up microservice ecosystems, making sure that we have the interaction patterns set up. Now, hopefully, this session today has kind of covered some of the known artifacts that we have in the Java ecosystem, some of the things that we're on the fringe of all experimenting with, and some of the far-out hypothetical stuff. So I hope it's been enjoyable. I've been Steve Wallin. John Dwimowicz has joined me on the line today, and I think we have a few minutes left for questions.
Indeed, that was a great session. So at the moment when you went into the quantum computing, it got really technical for me. That was great. And seeing that,
test.
Yeah, seeing that you can actually play with a small implementation of quantum computer was excellent. So I know that we have at least one question from the IRC, and I will try to find it now. If anyone in the IRC has any more questions, we have a couple of minutes, so you should type them in right now. So the question comes from Michael Rasmussen, and it's about the dynamic JIT, right? So the question is, he's wondering how does JIT as a service will work if you don't have compatible environments? Will it work with just identical open operating system architecture, or does it just store metadata and then it is more generic, so to speak?
I think that's one for you, John.
Yeah, I guess so. If I don't know is the acceptable answer, I would go with that. But I do understand the question. The question is, if you're going to move your JIT out of the address space, a bunch of the assumptions that it knows about the runtime that it's, or the environment that it's running in, the processor it's running on, so the context that it's running on has to be available to the service so that it can make the same decisions. So how will it work reasonably? I mean, you could build one that's cross-architecture because there are such things as cross-compilers. You could build one that serves up different versions. So, for example, our JVM isn't actually tied to Java 9. It runs under Java 8 as well. The way we say it is the JVM is the JVM is the JVM. So you certainly could build a JIT as a service that could just generate arbitrarily code for arbitrary different versions of Java. And I think that's the most flexible way to go because you will not tie yourself and have to update the service. One of the ways we think of it, and so some of this is new and we're planning to work some of these issues out, one of the ways we think of it is, think of it as if the operating system provided you the JIT compiler. So you could put it in as a trusted component as part of the platform. So it's generating code for you, which means you can share the code. You can generate, I would say, different versions of the code depending on what the request was, whether it's relocatable, shareable, process independent, that kind of stuff. So the answer is there's a lot of ideas on how and what flavors to solve. Which ones will be prioritized first is, I guess, up to the community who wants to work with us. But there's really no unsolvable problems in deciding how you would move the JIT out and then get it enough information to give you code. And I don't think that's an unsolved problem. There's lots of issues in terms of refactoring the code, but otherwise it's as I say, I can say it with a smile because I'm going to say it's just work because I don't have to do the work. And the team who's listening now down the hall is probably getting ready to come and talk to me about this exact wording. But so yeah, the question's a good question because there are those details that have to be worked out. But I think there's kind of a well-known way to get there. It's just how long it'll take us. And if you have ideas on how you would do that, that would be great too. So thanks.
Excellent answer. And a follow-up question from Manny Sarkar. He says it's a question for Steve, but it's also a question about the JIT. Like, do you have a link to some resource, like a tutorial how to, or documentation about how to connect this JIT into the OpenJ9? Like, does it use GMCI, or can you just share either now or maybe later after the session somehow with us if you have any documentation about that?
Yeah, so the easiest way is to go get a build from Adopt OpenJDK, and OpenJ9 as a JVM. There are binary builds available today that people can go and play with. But the JIT that we've been talking about is contained in OpenJ9, which is an Eclipse project. So if you go Eclipse OpenJ9, you'll find the project homepage, which has descriptions. Equally, you can go get binary builds at Adopt OpenJDK that are linked from the Eclipse project page. Yeah,
so just to be real clear, today, OpenJ9 is just a alternative JVM to something like a hotspot, and there are 5 or 6 alternative VMs to both of our VMs as well. So there's lots of JVMs out there. OpenJ9 runs the OpenJDK libraries, and as Steve said, you can get a build from Adopt OpenJDK. As we look at features like JIT as a service, it will then be part of an Adopt OpenJDK build, where you can get a fully functional build, and the questions on how you would set up a configuration, security, and other things for trying to offload JIT compilation to another place so that you don't have all the address space and the costs locally. That'll be worked out as I talked about earlier. So I think that's a good question as well.
Excellent. Great answers. Thank you so much, John. Thank you, Steve, for the session. It was quite insightful. Unfortunately, it's time when you have to.
Yeah. I want to say one thing. Thanks to the Pakistan JUG for sponsoring this. I'd like to get there one day and say hi, but thank you very much, you guys, for sponsoring this. So I appreciate it.
Thank you.
Yeah.